Okay, so now let's begin our presentation. Today, the topic for my presentation is evaluating the performance of LDPC codes and the decoding algorithms of the LDPC code. So, this is the table of contents for my presentation, and there are four sections today. The first is the introduction, the second is the description, the third is the evaluation, and the final section is the summary and the conclusion. Yeah. So first, let me introduce something about the LDPC code. The full name of the LDPC code is like the low density parity check code, and is proposed by the Gallagher in 1962. It's essentially a linear block code and is very close to the channel limit. Current studies have shown that the LDPC code is the code with the strongest error correction capability in channel coding, and a simple decoder structure can widely used in deep space exploration and things like the satellite communications and other fields. Yes, because of its outstanding performance, it has attracted much attention. Yes, and is a 4G preferred coding scheme for mobile communications and the deep space communications and other fields. So for now, then I will talk about its how to define the LDPC code. And the LDPC code checkmarks will have things like three main properties: the ratio of the weight column and the weight row, and the code length of the matrix is far less than 1. And the second is like any two columns or rows have at least most one at the same position. And the number of any linearly independent columns should be as large as possible. Yeah, so according to the initial definition of the LDPC code, Gallagher have give instance of the check matrix whose weight of the column is 2 and the weight of row is 4. Yeah, it's like the check matrix in the PowerPoint. And what's more, the LDPC code could be like divided into two categories. Yes, if every row has the same numbers of 1 and every column has the same numbers of 1, we can call this kind of the LDPC code as regular code. Otherwise, it should be things like the irregular code. Yeah, and the example matrix here is regular code. And like as we said before, the LDPC code becomes popular this year because of its outstanding decoding performance. It has two main decoding methods. They are belief propagation based algorithms and the bit flipping based algorithm. And like a bit flipping algorithm is a hard decision here, and we can call decoding process as hard decision if the bit value is transmitted during the decoding process, and it has lower decoding complexity and is easy to implement in engineering field. Yeah, so here is a flowchart for the bit flipping process. You can see, as you can see in the flowchart, during the decoding process, the received real number sequence is first demodulated by the demodulator, and then the hard decision is performed to obtain the hard decision what one sequence, and finally the obtained hard decision sequence is sent to the hard decision decoder for decoding. Yeah. Then we will talk about the belief propagation algorithms. Yeah, it is a software decision. Yeah, the belief propagation algorithms is an iterative decoding algorithm based on the tangraphs and is a soft decision decoding. And during the iterative process of the belief propagation algorithm, the message is passed back and forth between the variable node and the check node through the edge on the tangraph. Yeah, so here is a flowchart for the belief propagation decoding. um, And in this paper, we will mainly focus on the performance of three improved decoding algorithms based on the bit flipping. The first is the WBF algorithms. The full name of it is the weighted bit flipping, and the yeah, and the second will be the improved weighted bit flipping algorithms, and the third will be like the implementation efficient reliability ratio based weight bit flipping algorithm. And first we'll talk about the weighted bit flipping algorithms. You can see just by adding some credible information at the decoding receiving end, and we can greatly improve the bit flipping algorithm's error correction performance. And however, the algorithm does not distinguish the degree of influence of different bit nodes on the verification failure in theory. A bit node will with like the smaller channel reception value is more responsible for verification failure than a node with a large channel reception value. So there was an improved algorithm called the IWBF algorithm. Yeah. And the third is like the IRRBF algorithms. Just by eliminating the redundant calculations containing the equality function of the RWBF algorithm, and also propose an effective RWBF algorithm. Its abbreviation will be like the IRRWBF. In each iteration of the IRRWBF algorithms, only the hard judgment result of one bit node is flipped, and then only the checksum of the check node containing the bit changes in each iteration. And finally, in this paper, we used the MATLAB to compare the performance of the algorithms mentioned above with the normal BP algorithm, and with compare with the uncoded case. And the channels used in the simulation are all AWGN channels. Yeah, and along with the binary input and with modulation methods used. Yeah, well, all these things are all baseband like the BPSK modulation. And in order to simulate the decoding performance of the LDPC code, here we build a simple system which will do all the stuffs. The following is our diagram of the LDPC decoded simulation system. Yeah, you can see there's a source generator, and the source will be passed to the LDPC encoder. Then the BPSK will modulate the LDPC code, and it will pass through the AWGN channel, and finally it will be demodulated by the BPSK, and finally, yeah, the LDPC decode by the through the LDPC decoding process, and finally we will have the result of the simulation performance. Yeah, and let's say it's the final simulation result. Even though the hard decision decoders give better results according to the previous analysis, these decoders still cannot provide as good performance as that obtained in the BP decoder. And also know that, as you can see, like the IWBF decoder presents the worst bit error uh, the BR values, even though its performance is almost the same as that of the uncoded case. So, like when compared with the uncoded case, the improvement achieved by the BP decoder is nearly like 2.5 dB for BR of like the -1, the power to the 10, yeah. And during the process of writing this project, or say during the process of the researching LDPC codes, we mainly completed the following aspects. Like the first is like we briefly introduced the LDPC codes, and the decoding process is roughly explained. Also, like it can be divided into soft decision decoding, like the BP algorithm, and the hard decision decoding, the bit flipping algorithm, and we introduce some improved algorithm based on the hard decision decoding. Yeah, like the weighted bit flipping, the improve the weighted bit flipping, and the IRRWBF. Yeah, the improvement, the ratio based weighted bit flipping, and finally we just simulate the BP algorithm, the WBF algorithm, and the IWBF algorithm, and finally the IRWBF algorithm under the AWGN channel, mainly focus on the improved algorithms based on the hard decision decoding. Yeah, that's seems like all the stuff I had done in this project. Yeah, and finally, thanks for watching this presentation.